Get right into it. So I think this is probably the first red day we've seen in a while. A lot of it stems from South Korea. This statement made by a politician saying like, "Hey, maybe we should redistribute the gains." The market's like, "Whoa." Also, I just think like we need a bit of a back off. Largest down is really I don't doesn't show percentages here, or I haven't actually configured it to. But yeah, memory names, of course, hit hard. A bit around optics. Data centers are kind of just doing their thing. Nothing too insightful. But today I really want to get through the Bernstein report about data center connectivity. So let's find that. Okay. So, according to SK Group Chairman Blah, who also oversees SK Hynix, if companies like SK Hynix do not increase their memory supply, customers will find ways to use less memory by optimizing their inference software for much lower utilization. Yeah, I don't really think so. It's like, oh, we'll just build better architecture. It's like, yeah, that actually takes a lot of work. And you're still running into hardware limits. You can't just magically shift the problem away to slower hardware, otherwise we would have solved it by now. So, okay, this is kind of interesting. I'm keen to see. Early Rocket Lab equivalent for humanoids. Serve robotics. Anyway, sorry, getting a little sidetracked here. Qualcomm is the problem child of the current chip rally. Let's see what this is about. So, the company is selling the dream that it will become a major player in the data center, AI chips from AI accelerators to CPUs. Qualcomm, it does not deserve it. Let's see. The core business is eroding. Materially lower earning for, okay, it's paywalled. So, yeah, I also don't like Qualcomm when I did do some research into it. So, roughly checks out. Anyway, let's see. OpenAI's $20 billion Cerberus commitment could give it up to an 11% stake in the chipmaker through future equity tied to future chip orders. That's interesting. Another creative financing deal. Okay. Dun, dun, dun. Data one. Something. Let's see. So there was this Bernstein report, and I really want to dig into that around data center connectivity. So let's Bernstein data center. Let's see if we can find that. Yeah. I think this might be private or to institutional investors. Okay. I mean, let's see if we can quickly. Let's see if we can find anything here. No, this is probably going to be paywalled well. Anyway, I feel like people on Twitter will give us little drips of it. So let's go through the Twitterverse to find it. Okay, so massive copper shortage. Okay. Data center connectivity. Let's just find these keywords to see if we can get our hands on a little bit of that report. Let's go latest. Okay, so Lumentum and other connectivity suppliers as key beneficiaries. There we go. Okay, so over here you have your actual server that will go inside the rack. The rack will go here. You've got climate control. And what is the red? You've got your power systems. Okay, you have your transformers. I guess these are the transformers. So you've got your power. You go down to your transformers, and you have your power cables. You've got your backup power here. Then it feeds into, so all of this is copper and fiber. And you have air handling, networking rooms, chillers, cooling towers, bus bars for power/connectivity, and water storage. Cool. I mean, that's a nice little layout of a data center. Doesn't help us too much. Okay, let's keep scrolling. Maybe we find other people have let out little slips. April CPI inflation 3.8% versus 3.7. Core CPI 2.8 year on year versus 2.7. Energy accounted for over 40% of the increase. Interesting. Now, so I didn't realize this, but it looks like AWS might be using EMIB for a lower end version of Trainium through MediaTek, similar to the TPU v9 program handled by MediaTek. Next generation Trainium teams to likely use both EMIB and I always forget the acronym, but it's around packaging. Co something something thing. Anyway, let's go to Claude here because I don't like not knowing exactly. List to me. I am semi-proficient in semis. Cool. So AWS is using two different advanced packaging technologies used for its custom AI chip. Okay, so EMIB, Embedded Multi-Die Interconnect Bridge, is an Intel's advanced packaging approach. Instead of putting multiple chiplets on a shared silicon interposer, which is expensive and size limited, EMIB embeds small silicon bridges locally in the organic substrate only where two chiplets need to talk to each other. It's generally cheaper and more scalable than a full interposer, but offers less bandwidth density. Okay, that kind of thing. Then chip on wafer on substrate. That's what it is. It's TSMC's approach. And it uses large silicon interposer to connect multiple dies with very dense interconnects. It's the gold standard for top-tier AI accelerators, but it's expensive and capacity constrained. So basically, Amazon is using both approaches. So let's just say, can you create an interactive diagram prototype image that shows the difference between the two packaging approaches so I can understand it visually. Cool. Let's let that fire off. Sweet. I want to dig into this as well. But this I know is just going to take a few minutes. So let's go back. Nebius trimming shares into earnings. Let's see. Nebius earnings. When are they? May 13th. Oh, tomorrow. Cool. That is going to be exciting. One of the neo clouds that actually has its shit together for once. Okay, our little prototype is done. Cool. So chip on wafer on substrate. You have your organic substrate, you have your silicon interposer that's the full width, and then you have your memory and your things on top. Okay, so this is your 2.5D chiplet technically, where you're putting everything on the thing. Oh, this is really nice as a diagram, by the way. Good job, Claude. So versus embedded multi-die interconnect bridge. Okay, so it's just, that makes sense. Embedded multi-die interconnect bridge. It's literally just you're using it where the chips need to communicate to each other rather than the whole surface. So it's a thin silicon highway connecting everything. In EMIB, those green bridges are tiny and only exist at specific junctions where two chiplets meet. So that's why chip on wafer on substrate, I think I need a chip on wafer on substrate, yeah, offers higher bandwidth, more wiring, more connections, but it's expensive. EMIB is good enough and you only pay for connectivity where you actually need it. So I want to ask a question that chip on wafer on substrate has a lot of wasted connections though, isn't it? Like, why does having more surface area in places where you don't need connectivity lead to higher bandwidth? This could be a dumb question, but I just want to really clarify it for myself because when you see tweets like the one we just thing, you don't want to be like, oh yeah, okay, cool, cool. It's like that's a really intellectually lazy way of approaching this stuff. So let's see what Claude comes back with. Okay, the fill interpose is somewhat wasteful in terms of area. The advantage isn't about having connections everywhere. Okay, so the key is trace pitch. Both EMIB bridges and chip-on-wafer substrate interposers are silicon, so both get the same fine lithographic wiring. The difference is how wide the connection interface is between the two chiplets. With chip-on-wafer substrate, the interposer extends under the entire edge of each chiplet. So you can run thousands of traces across the full length of the shear boundary. With the EMIB, the bridge is a small piece of silicon, so the window where chiplets can talk is physically narrower, fewer traces fit across. Also, the other bit is multi-hop routing. If chiplet A needs to talk to C, non-adjacent, with chip-on-wafer substrate, you have silicon the whole way. Versus EMIB, you have to go through the bridge, through the organic substrate through the bridge, which means higher latency. So, okay, it really is like, do you want highways everywhere, or do you want highways in this one very narrow piece? So cool, that makes sense. We learned something new. And this is, I honestly really recommend doing this exercise when you're going through a lot of semiconductor related things. Take the time to actually understand what the stuff is. Cool. Let's move. So it seems like EMIB has more capacity. Okay. Global orders for gas turbines will decline slightly this year, but remain strong. I wonder if this is just because like the backlog is so big. Like, why would you have orders from north of what do you call it? 5 years or 4 years, 2030. So, yeah. Cool. Moving on. eBay has rejected GameStop's acquisition offer and called it neither credible nor attractive. Cool. Palantir CEO meeting with the Ukrainian president. This is turning into a game of telephone. Okay, if you can unlock spare capacity on the system, then you're good. But okay, so data centers can actually lower consumer bills. So really what we're discussing is like data centers and energy usage for local residents or whatever. Interesting. So really it's saying that GridCare is saying that data center, you do the hard work with all the partnerships and everything, and then we will piggyback off it. But a lot of data centers don't want to do that work. And this is kind of where the challenge really lies. Okay. $0 to $2 million in 6 weeks. That was pretty fast. Nice. Okay. Yeah, LM replies on Twitter are definitely thing. Okay. TE crushed their Q1 earnings. 178 million revenue versus 100, EPS of 1 cent versus is 14. Okay. Guidance of 4 gigawatts from G1 Dallas and high end of the range. Well, let's check out the chart. I haven't checked T1 in a while, but I have it on my personal watch list. Well, down on earnings, classic. So year to date, it hasn't actually done too well. It had this big run up from $1. So still kind of materially up from like October and November lows, but kind of been a little range bound through that time. So let's see if we can learn a bit more, because they're energy producers, and I do think energy, of course, is like the ultimate bottleneck. I like to sometimes actually go into earnings and on Reddit, sorry, and see what people say there. Yeah, okay. Uh, Not sure. There's seems to be a lot of controversy around it. I know they used to be like an ex-Chinese thing, and uh, there's a bit of controversy around it. But I don't know. The EPS just don't seem that attractive, like just off the bat. So, kind of moving on. Dun dun dun. Let's see. We'll also take the under on whatever people are projecting small medium reactors contribution is the next 10 years. So the U.S. develops small modular nuclear reactors for commercial shipping. Okay, what is this about? So in RFI about SMRs to be commercially viable and system transition lens, bunch of collaborations. Okay, still seems very early stage. Don't think it's anything super material here. Nebius reporting earnings. Okay, so this guy's been a semiconductor engineer. I put some money into Cerberus IPO, but with competition being so fierce, how much allocation I'll get seems to be decided tomorrow. So they're going all out with one wafer. They packed it with 970,000 small AI cores, each with 48 kilobytes of SRAM, totaling 44 gigs. Interesting. So let's maybe go a bit deeper into Cerebrus again and really kind of thing on their signal. Okay. Yeah, so the whole thing, if you're not across it, is that they don't cut chips into, it's basically just one big chip. So it does really well with speed because you can get really fast tokens that get decoded and like put through the system, but effectively you have problems with SRAM capacity. Yeah, so it's quick to generate tokens, but far expensive to generate each token. That's kind of like the trade-off you're making. And yeah, I do think there are use cases for it, but it kind of feels like we're not fully sure what those are and how much you're overpaying for future growth. Okay, so Tetri talking about the inference shift. Let's dig a bit deeper. I feel like everyone's just waking up into this. So the GPU era. Just as drawing pixels on a computer screen was a parallel process, which meant there was a direct connection between the number of processing units and graphic speed, making AI-related calculations was a parallel process. Cool, NVIDIA did this. This is a bunch of stuff. Okay, so training isn't the only AI workload. The other is inference. Inference has three main parts. Prefill encodes everything the LM needs to know in an understandable state. It's highly parallelizable and compute matters. The first part of decode entails reading the key value cache, KV cache, which stores context including the output of the prefill step to make the attention calculation. This is a serial step where bandwidth matters, but the memory requirements are variable and increasingly large. The second part of decode is the feed-forward computation over the model weights. This is also a serial step where bandwidth matters and the memory requirements are defined by the size of the model. The two decode steps alternate for every layer of the model. They're interleaved, not in sequence, which is to say the decode is serial and memory bandwidth bound. For every token generated, two distinct memory pools must be read. The KV cache, which stores context and grows with each token, and the model weights itself. Both must be read in full to produce a single output token. So I think one thing I want to do is get Claude, can you please create a nice diagram like you did above explaining this? I roughly get it, but I don't feel like I'm very clear on it. So let's just go a little deeper. should be almost done. Let's maybe do a bit more Twitter scrolling in the meantime. Yeah, agreed. It kind of still feels like science project vibes. There's still a lot of risk involved with it. A mid $80 billion valuation. That is kind of ridiculous. 50 billion. Insane. And we still haven't even got to OpenAI and Anthropic. Those are going to be even more crazy. Cool. Okay. Let's see. All right, so training and inference, we're almost done. Nope. Okay, benchmark 7 still owns more than 20% of Cerberus, who are over 20x oversold on their IPO. If it trades at even half of what Shanghai priced more threads and Cambricon, it will be 500 billion in less than 2 years. Number one fund in VC history. Is it? Let's see. VC's brutal. Benchmark Fund 8, $460 million fund, 2013 vintage, acquired 20% of Cerberus in May 16 for $12 million. Then they invested another $300 million and got valued by 80% on the initial check. So the initial check will see a 500 return and generate a 20x at the fund level if they see greater than 100 billion market cap. The top 30 vintage. So where is it? Oh, okay, it's just breaking down the math. Interesting. Let's go back here. Do we get our little tabs? Okay, so each training step, parallel compute, forward plus backwards pass, massively parallel within each GPU. No, break this down in a more fundamental way. This still doesn't make sense. I'm trying to understand this at a system level. Okay, that's gonna take a bit. Dun, dun, dun. Okay, that's because I'm on them. I'm like, why is everything about Cerberus? Anyway, let's get out of that little rabbit hole. There's a 300 million market cap robotics company in Taiwan, Aurotech. Interesting. Cool. Unitree. A new. Okay, it's a robot that can. So what is this? It's a humanoid that you climb into? That is so cool. Okay, so you sit inside it. And then how does it work? Do you get like a joystick or something? No way. That is so cool. Seriously, the future is here. That is just insane. Okay. Okay, so Thinking Machines. This is the audio doesn't really come out too on the stream, so I'll probably check that out later. But it's like a real-time inference uh, model, something rather than being turn-based. It's actually like very real-time, you could say. This thing is still going. Okay. So a GPU is three parts. So you have compute cores, do the math, bandwidth pipe, HBM memory, stores the data. Cool. Then GPU 0, compute HBM, NVLink, links them all together. Cool. Then in training, every GPU talks to every other GPU. They share results before the next step can begin. So the compute cores are the bottleneck. They're working flat out, but between each step, everyone has to wait for the slowest GPU to finish sharing. So the network pipes limits how fast you can do steps. So with fast compute CUDA plus fast network NVLink, you can do what you need to do. But with inference, okay, the GPU must read all the weights and the full key value cache from memory. That's terabytes of reads for a tiny bit of math. So the compute cores are starved. They finish the math instantly, then sit idle waiting for the next chunk of data to arrive from memory. So, okay, it's really just, okay, I mean, I knew this was just the way he's gone about it is going a bit more into detail, that inference is memory bound. Yeah, so I mean, like, I think from a high level, like, yes, things are shifting to be inference based, but like Cerberus still has so many unknowns with its technology. Like the fact that you can only store, like, have 44 gigs of let's say DRAM in whatever form, SRAM or whatever, limits what you can actually do. Like, I think for small language models it makes sense, but if you have a big machine, you'd want big capabilities. It's like if they could shrink it and get the same output, that would be great. But I don't know. It feels like a science experiment, and people like are now being like, oh, like inference is going to be big. It's like, yeah, of course, but how you express that view matters just as much as believing that inference is going to be big. Cool. So March 5th, this guy called the DRAM bottom. April 7th, bargain at Century, $62 to $818 all-time high. April 7th, interesting. Dun, dun, dun. This here's Compute X. What is Compute X? Oh, very cool. It's in Taipei. All about computers. Very cool. This is in June 2nd. Okay. Interesting. What else? Cool. Well, happy to call it here. Nothing too much more to check out. Yeah, I'm not really seeing anything more that I want to see. Cool. Well, thank you all for tuning in. Appreciate everyone who's jumps on and hears me just speak about semiconductors for a bit. Anyway,